All right, next boards go up, please. Problem. I want you to use a triple integral in cylindrical coordinates to find the volume of the thing, that cone that we just did in the last problem, above the XY plane. So you might even be able to use some of those things I talked about when I was explaining what that shape was when you're setting up your bounds. So, additionally, before I tell you to hit pause, additionally, this one is really similar to one of the sample boardwork type problems that I had you do um, yesterday or whenever the last day was. Anyway, so hit pause now. Give it your best shot. Okay, before I show you the answer, I'm going to tell you I got 1,000 pi/3. So let's see how I did that. Um, I'll scroll through real quick, and then I'll go through and talk about it all. All right, so I'm using the integral of 1 dv is equal to volume. That's just like the integral of 1 dA. Here the triple integral of 1 dv would be volume. In double integrals, the integral of 1 dA would be the area. Over whatever region we're talking about. The xy plane is z equals 0, right? We went over previously that this shape was a cone, right here, this cone, height of 10. Um, and I can write it as z equals 10 minus r, right? That's how I would write that in cylindrical coordinates. So since I want the air or the volume of that above the xy plane, I go from z equals 0 because that's what the xy plane is. If I'm in this plane right here, x-axis, y-axis, then I have a height of 0, so that's z equals 0. Um, uh, where am I? Oh, so I'm talking about bounds right now. So I'm going to go from z equals 0 up to z equals 10 minus r. Now I need to figure out what my r and my theta bounds are going to be. So what I do is I take that xy plane and I figure out where this cone hits it. So to do that, I set z equal to 0 in z equals 10 minus r, right? So I get 0 equals 10 minus r, pop the r over, I get r equals 10. Well, that's this thing, right? So this is the intersection of that surface with the xy plane. And you should know how to get that region with r's and thetas. I just let r go 0 to 10 and theta goes 0 to 2 pi. And that'll get me that full circle just like it always has whenever we've been in blah, 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 polar coordinates. My brain, it can only do so much here, people. Okay, so and then so look here, I got that, right? And then this z from 0 to 10 minus r, I also try to demonstrate that with this little line right here. Pick an arbitrary space in this 3D shape within the region that integrating over, and draw a line vertically from the low point to the high point. And you should see that we start at 0 and then we go up to that surface edge right there. So I do go from 0 up to 10 minus r. From there, it's just an integral, a whole bunch of integrals, right? Um, like it was talked about previously, we usually integrate with respect to z first. So I'm going to go integral from 0 to 10 minus r of 1. This entire r dz dr d theta is our dv. It's the r from the r dr d theta in polar. So integral 0 to 10, 10 minus r, or sorry, integral from 0 to 10 minus r. And then my r bounds goes 0 to 10. So that's this. My theta bounds goes 0 to 2 pi. So here, notice I'm integrating with respect to z, and it's like there's no z in there. So that means that I'm just going to, it's the integral of 1 dz, which is going to give me the upper bound, the upper z bound minus the lower z bound. So I could just get 10 minus r minus 0 times this r, so I get 10r minus r squared. That's the innermost integral. Now I'm down to a double integral, so I'm doing integral from 0 to 10 of this thing. This integrates to 5r squared, power rule. This integrates to minus 1/3 r cubed, more power rule. From there, I plug in r equals 0 to 10. I just math fract that thing. That gave me 500 over 3. And now I got to integrate that from 0 to 2 pi. So when I do an integral from 0 to 2 pi, I get, I just double this and multiply by, I double that guy and multiply by pi. I just essentially multiply by the 2 pi, multiply the 2 pi by that constant. It's the same move that I did here. Because there were no z's, here there are no thetas, so I just multiply the 2 pi by the innards. Up here I multiplied 10 minus r by the innards, which was an r. That's where that came from. So hopefully you either got that yourself or you were able to kind of see how we did that and recognize it from a similar problem the other day, and you're like, oh, now I see it. And I'm going to stop here and start a new video for our next problem.